All right, well, welcome everybody, including Miss Novak's class as well. So this was a compromise that we came up with so that you didn't have your test after Halloween. If at some point I go too fast, obviously you're watching this independently, so feel free to pause the video as you need to either catch up on your calculator or, multiply things through so you're not just copying whatever I'm just writing down. Really try and understand what this is because, like I said, it's a video, so you can stop it as much as you need if you need a little bit more time with something. All right, so what today's lesson is about is basically just different types of systems, whether we have two lines, a parabola in a line, a circle in a line. It's all about systems of equations. So this first one, it says solve the system graphically. So if it tells us to solve it graphically, that's all you really need to do. You do not need to solve it algebraically as well. For us to graph these lines, I would get them both in y equals mx plus b form. So I would subtract the x to both sides of the equation. All right, we're gonna have the same issue with the pen that I had last time. Okay, and same thing with the other one. All right, so if I go back to my Algebra 1 days, this first equation has a y-intercept of positive 6, so that's where I would start that line, is up 1, 2, 3, 4, 5, 6. And it has a slope of down 1 over 1. And because we're doing systems, I don't really know where the two lines are going to intersect, so I'm actually going to continue my line all the way across, and in a perfect world, would use a straight edge. But if we're doing systems, you absolutely should label your line. All right, so let me do the other one in a different color. I'll do the other one in red. All right, so that has a y-intercept of 2, and this has a slope of up 1, 2, 3 over 1. 1, 2, 3 over 1. 1, 2, 3 over 1. Down 3 to the left, down 3 to the left, down 3 to the left. And I think it's obvious where they intersect and at what point. Woof, that was not straight. Sorry. Okay. All right, so these two lines clearly intersect at a nice point right there, and so our solution is the actual point. So the solution would be 1, 5. All right, so if we move on and look at number 2, it says suppose that the second equation that we graphed, so the red one, so suppose the red one is replaced by the line x plus y equals 2. Plot the new line on the same set of graph. So let me go to a third color this time. So I'm going to plot this new one in green. So x plus y equals 2. Get it in y equals mx plus b. All right, so I have y is equal to negative x plus 2. All right, negative x plus 2. If I graph negative x plus 2, so again, that has a y-intercept of 2 with a slope of down 1 over 1. What I notice is if it's asking me what are the solve the system, that's what it's asking me, is to solve the system, but as I'm plotting all of these green points, it doesn't get anywhere near the blue line. And the reason why is because my blue and my green are parallel to each other. They have the same slope. So, same. I'm sorry about my pen, Miss Novak's class. My class knows it's awful. Same slope Therefore, the lines are parallel. So if this ever popped up and it said, what is the solution? You would say, no solution. Because they are parallel. All right, the last one is saying replace the same red line now with 2x equals 12 minus 2y. Okay, so let me see if I have one more color left. Yellow's not, I'll do black. All right, so I'm going to plot this last one in black. So we have 2x is equal to 12 minus 2y. I need to solve for y. All right, so it looks like my equation that I'm going to be graphing is y equals negative x plus 6. Well, I mean, negative x plus 6, isn't that the exact same line that I had graphed that was in blue? So if I end up graphing two lines and they have the exact same line and they line up right on top of each other, and I'm asking what the solutions are, there are infinitely many solutions because you're literally putting the same points on top of the same point. So every single point on the line is a solution. So since we have the same equation, there are infinitely many solutions. Pretty easy. Okay, sticking with Algebra 1, how do we solve system of equations using substitution and elimination? Elimination is going to be pretty important to us tomorrow when we get to tomorrow's lesson. So this one's going to be super important for us. Let me go back to blue because it's prettier. But substitution is just as important, which we'll see on the next page. So substitution, you typically want to isolate a letter. Sometimes it's y, sometimes it's x. So you typically want to isolate. All right, so when you do substitution, you isolate a variable, and then you substitute whatever expression you isolated into the other equation. So in example 1 here, it looks like the x in the second equation was much easier to isolate. So I'm going to solve for x. So I have x isolated. This expression is going to be plugged into the x in the other equation. So we have 3 times negative 3y plus 1. Distribute. Combine like terms. You could even move the 3 at that step if you wanted to. I'll move it now. I got y equals 1. Now that is not my final answer because remember, these are technically linear equations and our solution at the top of the page was a coordinate point. Right now we only have the y value of this coordinate point. To find the x value to finish the problem, to find the x value, you can honestly plug into either of the original equations or even the one that we came up with in this step here when we have x isolated. It's going to be equivalent no matter what you choose. Some teachers will say it's safer to go back to the original. I'm hoping that your math is solid by this point in your life, that you can just plug it into our rearranged one. We find our x value, and our solution will be negative 2, 1, x then y. Okay, elimination is slightly different, and that's going to be super important, like I said, tomorrow. Elimination is when you physically want to eliminate a letter to the best of your ability. So if you look at your x values, there easily can be a way that I can manipulate maybe this bottom equation so that my x's will eliminate. There's also a way that I could do something with the y's, but it would take a little bit more work. So if I want variables to eliminate, I need to have opposites, like inverse signs, additive inverses. So if the top is a positive 4, if you think about it, what could I multiply the bottom equation by to eliminate the x's away? And what I would have to do here is I would multiply the entire denominator, or not denominator, sorry, I'm still on rationals in my head, the entire bottom equation by a -2. The whole thing. So I distribute that 2 to every single part of that. So my top still 4x minus 5y is equal to -10. My bottom equation is now -4x plus 14y, and that's going to be equal to a -8. So when I can combine these together, I combine them straight down. My x's are lined up, my y's are lined up, my equal signs and my constants. My x's will cancel each other out. What I end up here with is a 9y, and what I end up here with is a -18, and then super easy, I have my answer for y. And then same as the last one, I need to plug back into either of the original equations and solve for x. It does not matter which one you pick. I don't know, let's just pick the top one, I guess. So 4 times x minus 5 times -2, so I'm replacing the y with the answer that we got. Subtract 10 to the other side. Got my x value. And so my final answer, whoop, that was bad, but oh well. You guys can read it still, right? I'm like asking you questions as if you can reply. All right, -5 comma -2, perfect. Okay, up to this point, we haven't really had to touch our calculator much, but now we're going to do a line and a parabola and talk about those intersection points. So there will be times where I will bring up a calculator. Now my calculator is a little out of date, but all the buttons are in the same places that yours are. So just kind of bear with me as we do this. So I'm going to graph the line in blue, and I'll graph the parabola in a different color. So if I graph the line in blue, we've already graphed a few lines already today. So this has a y-intercept of 3 and a slope of down 2/1. So we can get that one out of the way, label it, and then we can deal with the calculator part. Again, I don't know where the line and the parabola are going to intersect. So I'm going to bring the line all the way across the page. Sorry, this is on a tablet, so it's not the straightest of lines, but I think you'll get the idea. Okay, so I have this calculator app here. Oh no, where'd it go? All right. There we go. In the y equals screen, if you go to the y equals screen in the upper left-hand corner, if you have anything in there, clear it out. And in this spot, we want to type x squared minus 6x plus 3. We then are going to go to our table of values and hopefully find, so second graph, hopefully find some symmetry in the numbers. Now obviously if I'm giving you a 10 by 10 grid, it's probably going to fit within a 10 by 10 frame. So that should give you kind of an idea of where to look. So it looks like 0 to 6 is a pretty nice window here. It's going to be hard for me to keep all my numbers and this calculator on the screen. So hopefully your screen looks like mine. I'm going to plot from -1 to 7. Those are the numbers that I'm going to plot. So let me write down my table of values for my parabola. So what did I say? -1 to 7. All right, -1, it was 10 according to my calculator, so you guys can keep it in front of you. Once I touch off the calculator screen, it pops back to this. Okay, that's a -2. At +2, it's -5. Our vertex point there is going to be 3, -6. And then it starts making its way back up. You'll notice, repeat. Oh gosh, what did I do wrong? Oh, nothing. I didn't do anything wrong. Sorry. All right. So it'll have a nice little pattern, some rainbow pattern if your teacher called it that in the past. But this is what we call our vertex point. So it'll be like our turning point. All right, so let's go ahead and plot these dots. I should have done that in a different color just so I could have corresponding colors, but I'm going to do my, go away. Okay, I'm going to do my parabola in red. All right, so -1, up 10. 0, up 3. Ooh, that looks nice. 1 down 2. 2 down 1, 2, 3, 4, 5. 3 down 6. 4 down 5. Ooh, there's another nice one. 5 down 2. Do, 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 do. All right, nice curve through this. Try not to make shark teeth to the best of your ability on a tablet here. All right, now I think it's pretty clear where our solutions are. We have 2 solution points. So I'm going to say my solutions are 0, 3, and 4, -5. This problem says solve algebraically, whoops, and verify graphically. We kind of did it the other way around, sorry. Solve algebraically is actually what we're going to do using substitution, which we did on the last page. Both of our y variables have already been isolated. So the hard part's already done for us. We're literally going to set the 2 pieces to equal to each other. So I take the line, I equal it to the parabola, and I get everything on one side because I'm going to solve for x by factor t-chart. Okay, I get it, this nice quadratic, super nice because it's just GCF. And one of my x values is 0 and one of my x values is 4. Holy moly, look at that. That matches our x values of our points that we already got. All we have to do is plug it back in and get the corresponding y's. I strongly encourage you plug it back into the linear equation. You'll have to do almost no work. So I'm plugging this into the top equation because that was the linear equation. All right, -8 plus 3 is -5. And there we have confirmation that those are our solution points algebraically. Okay, be prepared to do both. All right, moving on to the next example. It says solve algebraically and verify graphically again. This is not a parabola, however, because we have an x squared and a y squared. This is what we would call last year a circle. So if you were in geometry last year, which all of you were, this is a circle. It is centered at 0, 0 with a radius of 5. We also have a line, 4x plus 3y equals 0, and it wants us to solve algebraically first and then verify it graphically. So I guess we'll follow the directions this time. For us to be able to do substitution here again, you can solve for either of the x or the y in the linear equation. I would never try and solve for x or y in the top equation. You're going to end up with a square root in there, and that makes the whole world more difficult. So I'm going to solve for, just so it's already done when we get to graphing, I'm going to solve for y. And then we won't have to do it again for that part. So isolate the y. Okay. All right, so we isolated the y. Now what we're going to do is we're going to take this and replace it into the y equation for the circle. So we have x squared plus -4/3 x, all of that squared, is equal to 25. All right, we're going to square this up. So we have x squared plus 16/9 x squared is equal to 25. Let's see if my old calculator will be able to handle this or not. All right, so let's turn it on. Okay, so quit. All right, so we have 1 plus 16/9. So I'm just adding the coefficients of my x squared terms. Math bracket. All right, so if I combine 1x squared plus 16/9 x squared, I get 25/9 x squared. Okay, all I did was 1 plus 16/9 in my calculator, math fracked it, I got 25/9. Because now I need to isolate x squared. So what I'm going to end up doing is multiplying by the reciprocal on both sides of the equation, which is great because I get x squared equals 9. All right, square root. And when you take the square root of something squared, don't forget your plus and minus. So we get 2x values. Those 2x values have to then correspond to 2 y values because we are going to get 2 answers. So if we have the x value of +3 and the x value of -3 as our 2 x values, and we plug it into our equation, okay, I'm plugging it right into the equation that we had found from earlier, I get an output of -4 for this one, and I get an output of +4 for this one. So it sounds like when we go over to our graph, I'm going to keep my fingers crossed that my solution points are 3, -4 and -3, +4. That's what I'm going to hope for when I get to my graph. All right, let's actually graph this stuff. So let's go back and graph it and see what it looks like. So I'm going to graph this circle. We said the center is at 0, 0 with a radius of 5. So up 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Now this is really going to test me. Try not to make it look like a smushed box. I'll try and make it a nice circle here. All right, hey, that's not too bad. All right, the other one I'm gonna do in green. Oh, it's gonna look like Christmas. I'm gonna graph this one in green. The y-intercept is 0. Since there's nothing added or subtracted at the end of it, it's 0. So if it starts at 0 and the slope is -4/3, it's gonna go down 1, 2, 3, 4 over 1, 2, 3. All right, so I'm a little off. Down 1, 2, 3, 4 over 1, 2, 3. Up 1, 2, 3, 4, left 1, 2, 3. All right, I was a little bit closer on that one. 3, 4, 1, 2, 3. All right, connect the dots. And technically, since we solved it algebraically, we know that it would intersect at the circle there. But circles are really hard to draw and be accurate about it. So I strongly encourage, if it says solve a circle problem, it likely will say solve algebraically. Unless it's a horizontal line. So if we're graphing like a circle and a horizontal line, those are way easier to tell. Like if it asked me to graph, let me just change my color so that we don't get confused. If it asked me to graph something like find the solution point of the same circle that we have here in red, and something like y equals 5, that's a horizontal line. That one I could absolutely do graphically and be like, oh, crosses in one spot. So that one's easy. Whenever you have to deal with a slope like this one, it's harder to draw an accurate circle and actually find accurate points. So algebraically is always the safe bet. Okay, same idea for this one. This one actually isn't too complicated. I guess we could take the time. It's the same idea as the last one though. Okay. This circle is not centered at 0, 0. This circle is going to be centered at positive 2 comma negative 3, and it's going to have a radius of 2. Okay. So if we have a radius of 2 and it's centered at 2, negative 3, it's going to be a tiny circle. There's my little tiny circle. Okay. And the other one I'll do in a different color, I guess. Okay. Solve for y. Y-intercept of negative 3. Slope is up 1 over 1, up 1 over 1, up 1 over 1. I mean, there you go. There's a pretty accurate idea of what our solutions are. And if you wanted to, if you don't believe me that those are the two intersection points, then you absolutely can take the time and solve this algebraically and verify it. I know that's what we were supposed to do and verify it graphically. I just don't want you to have to watch this video for about 50 minutes, so I'm going to move on. Okay. We have another monster verification algebraically. I, again, am not going to take the time to do the algebraic solution of this one. I'm sure we'll post the answer key to this note packet anyways online. If you want me to graph the picture, I'll show you the picture and I'll tell you what the solution should be if you want to take the time to do it. So let me do the line. I'll do the line in green. So again, you get it in y equals mx plus b form. Ugh, what a pain in the butt. This is why this problem's so messy. It's not even a nice y-intercept. It starts at like 6.25. You know what? I'm not going to waste our time. If you want to check it out, check out the answer key on WITS. Number 7, though. This one we definitely want to check out. We only have the 2 more questions left and then we're done. I would put a star next to this one. This one seems interesting because this finally is stepping into the Algebra 2 world. All the rest of that was either a geometry or an Algebra 1 topic. Now we finally have to deal with, you know, some thinking and not just math. It says if the following system of equations has only one solution, so what that tells me, it's only going to intersect it once. What is the value of k that will make it intersect only once? So what we want to do is we're going to type this parabola in our y equals screen and get our table of values so that we can see what we're even looking at right now. So what is that? I mean, I could tell you what it is, but we haven't done that yet. That's part B of this unit. So I got to turn this guy back on. There we go. Y equals, clear out whatever was in there before. This is going to come out to be a parabola. It's actually kind of in vertex form, which is something we're going to dive into more in part B of this unit. All right, so we have the following equation typed in our calculator. We are going to look at the table of values, so second graph. Scroll until you see that symmetry. There it is. There's the beautiful symmetry that it is. So I'm going to write this table down. So remember, the quadratic is going to get the table. The rest we can figure out by hand if it's a line. All right, so it looked like I was going to go from 0 to 6 as far as the x values go. Those are the only ones that I'm going to plot. And then because you guys still have your calculator right in front of you, you can just fill in your table. This is -4, I'm sorry. +1, +4, 5, and then it should start coming back down. So here's our vertex again. All right, so let's go transfer that to the graph. So 0 down 4. 1, 1. 2 up 4. 3 up 5. 4, 4, 5, 1, and it's symmetrical all the way down. All right, so nice curve through those if you can. No shark teeth at the top. Okay. All right, so we have our line, or I'm sorry, our parabola labeled. It says that this equation, which is a horizontal line again, remember HOI, HOI stands for horizontal it has a zero slope, S-L-O-P-E, and y stands for the equation will be y equals a number. So we are literally looking for not a slope, we are looking for a number, like y equals 2, y equals 6, y equals -4. We're looking for a number for k that will only cross this graph once. Okay, if I draw any line, now don't draw these in, if I draw any line down here, obviously it's crossing in two places. But if I can draw a horizontal line and just touch that vertex point, that sounds like we might have a winner. So what is the equation of the horizontal line that will just touch the vertex point? Well, if it's a y equals, right, the equation is a y equals, well then the vertex point has a y value at 5. This is a horizontal line at 5, so we are looking for k must equal 5. Okay, so k would equal 5 so that that equation would only touch it once. All right, last one, and then we are finite. Not too bad. All right, consider the following system. All right, so we have a line and what appears to be a circle. It says the two solutions can be described as both imaginary, both irrational, both rational, one of them rational and one of them irrational. So we kind of have to think about what are they even talking about? Imaginary versus irrational versus rational. Okay, so if they are rational solutions, rational are like nice numbers, okay? Nice decimal, terminating decimals, whole numbers, even repeating decimals. Irrational would mean it's a decimal value that has no pattern to it and it would go on forever. Imaginary, we haven't technically learned imaginary numbers yet, but we have discussed it. And imaginary numbers would be if I get a negative under a radical. Okay, so if I'm going solve this algebraically and I get a negative under the radical, then our selection is going to be option 1. So let's see, consider the system below, let's solve it. So we'll solve it algebraically right now. So just to practice that one more time. We're gonna isolate, looks like y might be the easiest option. So I'm gonna isolate y. So negative y is equal to negative 2x plus 4. Divide everything by a negative 1, so we have a positive 2x minus 4. That is gonna replace the y in the second equation. So we have x plus 3 squared plus 2x minus 4 squared is equal to 8. Oh, your favorite thing in the whole wide world. We have a binomial squared, which tells you have to write it twice. Both of them actually are binomial squares, so you have to write both of them twice and FOIL it out. So we would have to FOIL. I'm going to save us some time. Once you FOIL out this one on the left, we get x squared plus 6x plus 9. Once we FOIL out the one on the right-hand side here, we get 4x squared minus 16x plus 16. Don't forget about the equals 8. All right, I have some quadratics going on in here. I have some x squared, so combine like terms, and don't forget to move the 8 over because we need to get it equal to 0. So once you take a second and combine like terms and move the 8, you end up getting 5x squared minus 10x plus 17 equals 0. Personally, I am not going to waste my time trying to triangle method factor this. I'm just going to solve it by using the quadratic formula, especially since some of my answer options are using words like irrational and using words like imaginary. There's probably something with a radical that has to happen in this question just based off of the options that they're giving me as the solutions. So I'm going to have to probably use some type of radical. So I'm going to use quadratic formula. So x equals negative b plus or minus the square root of b squared minus, 4 2ac all over 2a. That's a 4. I got excited. I started putting the next number down. All right. So if I go to my calculator and I type in that discriminant, which is, oh, by the way, that's the number underneath the radical. Okay, let's figure out what that number is underneath the radical. So if I go to my calculator, all right, and I type in 100, oh, come on, 100 minus 4 times 5 times 17, I get a negative 240. If I try to take the square root of negative 240, oh, too many negatives there. Square root of negative 240. My calculator tells me this. Error, non-real answer. So if it's telling me that it's non-real, that's just another way to say imaginary. So our answer is going to be option 1. What this would mean graphically, and I know it doesn't say that, but what this would mean graphically is wherever this circle lands, wherever it would happen to be, negative 3, 0, with a, I don't even know, a radius of like 2 radical 2, wherever this would be, it just means that the line never will cross. So there will be no intersection points, hence why they are imaginary solution points and intersection points. All right, perfect. 36 minutes, less than even a class period. So hopefully you learned something. Hopefully it refreshed something. And be prepared, at least my kids, be prepared for a mini quiz Monday based on this lesson. Do your homework, and we'll see you on Monday.